In two of my previous videos, I mentioned the same thing, which is if you use DNAT to hijack your client's custom DNS requests, if you put your DNS server, for example Pi-hole, within the same VLAN as your client, the hijack will fail. Recently, I received a comment from Jeff, a viewer. He provided a working solution to the problem. In this video, first I'm going to show you the original problem when Pi-hole and your DNS client are in the same VLAN. Then we will discuss the solution, how to make it work. Later we will dig deeper, go to the backend to understand why we even need a new firewall policy for the same VLAN network traffic and what this Masquerade NAT rule really does. Okay, let's get started. Let me show you the original problem. I have two VLANs, default network and the VLAN admin. In each VLAN, I have a DNS client as shown in the lower part of the screen. For security firewall rules, to simplify this scenario, I have completely default firewall policies. All the gray color ones, they are disabled. So I do not have any single active custom firewall policies. If I go to routing for NAT, you can see I have two DNAT rules. They are used to hijack the DNS queries for each VLAN to the Pi-hole server. So if I show you the first one, the default network one, it's very simple. As long as the destination port is 53, which means it's a DNS query, I will hijack it to this IP address, which is for the Pi-hole server installed in VLAN admin. Then if I go to the second DNAT rule, it's similar, but it's for VLAN admin. Then another difference is, remember the Pi-hole server is installed in this VLAN, right? Of course, Pi-hole server does need to access internet to get the domain name resolved, right? So when I hijack DNS queries, I want to exclude Pi-hole server. So this is how I exclude it. For source, I specify the IP address for Pi-hole, but here I say match opposite, which means as long as the DNS client's IP address is not Pi-hole, I will hijack it. Okay, two very simple DNAT rules, right? Then from the Pi-hole server, if I go to the DNS setting, you can see I changed this interface setting so that it will serve the DNS queries from all VLANs, not just the admin VLAN. Now I'm ready to show you the issue. So from the default network client, if I run this dig command, I specify a external DNS server. I want to resolve x.com. Let me run it. Successful result back, and the client believes the query was done by the 4444 server, right? But in fact, under the hood, it was hijacked, and then the Pi-hole server returns this result. So for this default network client, it works perfectly. But if I do the exact same thing from this VLAN 10 client, the same query, run it again, see, it hangs there. It is failing. So then for these two clients, why the behavior is so different? Why for the VLAN admin client, it failed? To understand that, we need to understand what happens after the DNAT rule is executed. Then we will understand why for the second client, it failed. In the two client machines, let me launch Wireshark. Okay, then from the terminal, let me do the DNS queries again. From the default network client, run the same command. Successful. From the VLAN 10 client, same command is failing. Then go back to Wireshark. Let me stop capturing. From the successful default network, you can see the first packet is from the client itself, sent to 4444, right? And then the second packet is directly from the 4444 to the client. But what you don't see is in the router side. In the interest of time, I won't show you, but our DNAT rule first translate this 4444 to the Pi-hole IP address, and then Pi-hole will send the result back, and then the DNAT rule will convert Pi-hole server's IP address to 4444. That's why our client received the result. That's why it's successful, right? But if you look at the packets from the VLAN 10, of course, the first packet is still from the client to 4444. Then see what's wrong with the second one. The second packet is directly from the Pi-hole IP address to the client. Yes, the Pi-hole did reply, but this client didn't take this reply as the correct reply because the second packet was from the Pi-hole server, not from 4444. That's why the second packet was thrown away because nobody knew what it is for. And then that's why the dig command still keep trying totally 3 times. Every time it failed. Even though every time the Pi-hole did reply, but the client simply didn't take that reply as the correct reply because it's not from the correct IP address. When the DNAT rule translates the 4444 to the Pi-hole IP address, when the Pi-hole reply the query, because Pi-hole is in VLAN 10, the client is also in VLAN 10, which means the second packet is completely within the VLAN. It didn't go through the gateway at all, which means the gateway didn't have a chance to do any translation about this particular Pi-hole's IP address. That's why it failed. So I hope you understand what's the root cause for the failure. Then what's the solution? We need to find a way to force the second packet to go through gateway. Then we have a chance to translate the Pi-hole IP address back to 4444. Then our client will believe, okay, the reply is really from 4444, then it will accept it. That's what we need to do in our second part of the video. Based on the configurations in previous scenario, let's add one more NAT rule. More specifically, a Masquerade NAT rule. Go to Routing, under NAT, under Masquerade NAT. I already created one. Simply enable it. Then let me show you what's inside. It applies to VLAN admin. And this Masquerade NAT will only apply to packet which has the Pi-hole IP address as the destination and 53 as the port. Maybe this is confusing you. I will show you what's the effect of it from the captured packets. So now in the lower part of the screen, for the left side Wireshark, let me capture the UniFi gateways packets. I'm going to run a SSH remote capturing. Okay. Then for the right side capturing, I will simply capture the VLAN admin, the client's local packets. Start capturing. And then in the left side, you can see it's already showing up some packets, but they have nothing to do with our testing. Remember, I'm capturing the gateways packets, right? The gateway is very busy to accessing DNS for its own features. The other thing I want to point out is, see here, the third column is a custom column. It's the interface index within the gateway. So it's not super user-friendly. What you see is a number, but later I will show you what this number means. Let me do the same dig from the VLAN admin client. Run the exact same command which failed in previous scenario, right? Now we have the new Masquerade NAT rule active. Let's see whether it will change anything. Start it. See, it's successful right away. Then let me stop capturing in both Wireshark. First, let's check the simple VLAN 10's captured packet. See, from the VLAN 10 client, it sent query to 4444, right? And then it received reply from 4444, seemingly. That's why this DNS query was successful. So this is very simple from client 10. We need to find out the real answer from the gateway's captured packet. Remember I mentioned the interface index, right? So let me SSH to the UniFi gateway. See, in the left side captured packet, the first relevant one is this one from the VLAN 10 client to 4444, right? See, the interface index is 24. In the right side, SSH session, let me run command IP link. Then see, for each interface within the gateway, it has a number, right? This number is the so-called interface index. So you see what's 24? VLAN 10 interface for the LAN part. It makes sense, right? Because the VLAN 10 client wanted to access internet. So it will send to the VLAN 10 interface of the LAN part. Okay, we are good with the first one. And then see the second one, the only change is the interface index. Nothing else is changed. Then let's see what's 30. 30 is BR10. It's the VLAN 10 bridge. That also makes sense. The third packet is very, very crucial because in this very important step, both the source and the destination are changed. We need to understand which was changed first. To help us understand that, I need to show you the diagram iptables flow. This is already a extremely simplified flowchart, and I also make those steps which are not relevant to this video as the washed out color. So we only need to focus on this link. First, you need to know in UniFi gateway, both firewall rules and the NAT rules are implemented using Linux iptables. It's just inside iptables, there are multiple different tables. Firewall rules are in the filters table. NAT rules are in NAT table. During runtime, there is a combined flow for the packet's complete lifecycle within the gateway. In this simplified flow, you can see DNAT will be executed first. Then in the middle, you have the firewall rules. And then at the end, you have the SNAT rules. You may know Masquerade rules. They are just a special type of SNAT rules. To put it the other way, in our case, the DNAT rule will be executed first. It will translate the destination IP address. Then our firewall rule will be executed in the middle. Then the Masquerade rule will be executed at the end to translate the source IP address. Okay, this is very important to help us understand what really happened. Then let's go back to this crucial step. Because DNAT rule will be executed first, right? Then let's understand the destination IP address change first. It's changed from 4444 to Pi-host IP address. Why? It's because of our DNAT rule for VLAN 10. See, it will change the destination IP address to Pi-host IP address. Right? Then let's see the source IP address change. It's changed from the VLAN 10's client IP address to gateway IP address. Why? Because of our new magical NAT, a Masquerade NAT rule. It will translate the source if the destination is Pi-host. Why the destination is Pi-host? Because the DNAT rule was executed beforehand, so the destination IP address was already changed from 4444 to Pi-host. You can see without that existing DNAT rule, our Masquerade rule won't apply. And if we just have the original DNAT rule without the new Masquerade rule, the source IP address will not be changed. Then we will have the issue in the first scenario, right? So this is where the magic happens. So we have both source and the destination IP addresses changed. The destination was changed first, and then the source was changed later based on the destination's change. Hopefully it's clear to you. Then later, for example, this one is from the Pi-host IP address to 8888. Why? Because Pi-host is just a DNS proxy. It still needs a real external DNS resolver to resolve the domain name, right? So that's why Pi-host need to access internet. I won't waste your time explaining the ones in the middle. Let's directly jump to the other important one. See, from this packet to this packet. This is another crucial change. This is where the DNAT rule and the Masquerade rule apply to the return traffic. The Masquerade rule will change the gateway IP address to client's IP address, and the DNAT rule will change the Pi-host IP address to 4444. After this one, our client received the seemingly legit DNS reply, then everyone's happy. Okay, so you may think it's a easy fix. We are good, right? Not yet, because you may already noticed we are missing the crucial firewall rules. As I mentioned in the beginning of the video, we wanted to simplify the scenario, so we didn't really have the required firewall rules implemented yet. For example, we don't have this red block inter VLAN firewall rule, right? And for example, we don't have this green firewall rule to allow the default network client to access the admin VLAN's Pi-hole server, right? So let me implement this tool first. Then we need to continue the discussion because there is a much bigger confusion waiting for us. In UniFi Network Controller for the zone-based firewall, let me click on the cell from internal to internal. You can see, in fact, I already implemented the required firewall rules. I can simply enable them. This one, block inter VLAN, and this one, allow the default network to access Pi-hole, right? So resume, done. These two rules are so simple, so I don't want to waste your time explaining them. The only thing I want to show you is this particular one, block inter VLAN. I enabled this particular setting, syslog logging. So later we will use this one to understand the puzzle. Okay, now they are enabled. I didn't change anything else. So those DNAT rules and Masquerade rule, they are still active. So now in the admin VLAN, if I run the exact same previously successful DNS query again, let's see what will happen. See, it's failing again just because of our new firewall rules. Now you may be extremely confused. We are talking about from this client accessing this Pi-hole. This traffic is completely within the same VLAN. It's not even supposed to go through gateway, to go through firewall. Then why, just because we added a block inter VLAN firewall rule, this DNS query failed again, right? To really understand what happened, we need to SSH to the backend. I will show you the syslog. So in the left side, let me SSH to the UDM Pro. Okay, I'm in. So let me simply run this command, tail command, to show the updates to this syslog file in real time, right? Okay, a lot of things, there are noises. Okay, let me clear the screen. We have a fresh start. By the way, I also want to show you for the NAT rules we defined previously. Let me show you. Go to routing. Let's say for the DNAT rule for VLAN 10, I enabled this remote logging. Then for the Masquerade rule, I have the same option enabled. Okay, now in the VLAN admin client, let me run the exact dig command one more time. Okay, see what happened in the left side. Let me kill it. The second pair is just a repeat due to the failure in dig command, right? Let's focus on the first two. See what's the first log? It's the pre-routing for DNAT. Let me show you the iptables flow. See, pre-routing DNAT is exactly this step. Right? This is our DNAT rule. We can even see the DNAT rule name here. It's for the VLAN 10. Exactly what we expected. We all know the end result of this DNAT rule is to translate the destination IP address to Pi-hole. Right? Because we see this log, it means this DNAT rule was successfully executed, which means after this log, the packet's destination was already changed to Pi-hole. Okay, let's continue looking. Then this is the biggest puzzle for this video. What's this? This is firewall, and it is our block inter VLAN policy. And see, what's the source IP address? It's our VLAN 10 client's IP address. What's the destination IP address? It's our Pi-hole. It's ridiculous, right? So why for the same VLAN communication, it even went through firewall? It doesn't make sense at all, right? When we introduced this block inter VLAN firewall policy, what we wanted to achieve was to block the network communication between default network and VLAN admin, right? We never expected, okay, this firewall rule will block the traffic within VLAN admin. It shouldn't happen at all, right? Why it happened? We need to go through this flow again to understand it. Let's start from beginning. We have the DNAT rule. The original packet was from the VLAN admin client to 4444. That's why that packet need to go through the gateway. That makes sense. And then it goes through the first DNAT rule, no problem. So far so good. Then it goes through this part. And after the previous DNAT rule was the destination. The destination is Pi-hole. Because it's not the gateway, that's why the flow will go this way. It will execute the iptables filter, which is for firewall rules. I believe now you sense something, right? So if the original packet is from this IP address to this IP address, of course, there's no way it will go through firewall. But this situation is not for the original packet. In the original packet, the destination is 4444. That's why the packet is already inside the flow and it's at this step. Because the packet is already in gateway, already in the middle of the flow. There's no way the system will simply exit the flow. The system will still continue executing the flow, right? So that's why this poor packet has to go through the firewall. That's why our block inter VLAN policy blocked this packet. It's completely unexpected. It's the side effect of our block inter VLAN firewall rule, right? We have to have a workaround, which is we need to go to the firewall for this particular cell from internal to internal. We have to create this seemingly ridiculous firewall policy. Let me enable it. Let me show you. See, the source is internal and the network is admin. The action is allow. Then the destination is internal zone and the destination IP address is this Pi-hole IP address. So both the source and the destination, they are in the same VLAN. This firewall rule is so ridiculous, but it is really required. At the end of this new firewall rule, see, I also have the syslog enabled. Okay, so now we have this new firewall rule active. Let's try the dig command the very last time to validate whether it works now. In the left side, let me run the same tail command again and clear the screen a little bit. Then in the right side, run the exact same command. See, it's successful again, thanks to our new firewall policy. And then let's check what happened in the syslog. The very first log is the same DNAT rule, right? Nothing's changed. Then see, what's the second one? The second one is our new firewall policy. It allows this source to this destination. Then see, what's the new one? The third log, it is our previously created Masquerade NAT rule, right? According to this flow, it is supposed to be executed the last, right? That also makes sense. We finally completed the setup. We have to introduce a seemingly ridiculous new firewall policy to make this work. That's the main trigger for me to make this video. Okay. Let me summarize what we did. To resolve the original problem, which is if you have Pi-hole and client within the same VLAN, if you just rely on the DNAT rule, you will have a problem. To resolve that, first we need a Masquerade NAT rule. Then we have to have a new firewall policy created to enable this seemingly making no sense traffic from the same VLAN to the same VLAN. Okay, this is the end of the video. Thanks for watching.